So this is going to be a kind of a two-part lecture, one today, one on Monday, where we're building out like a network manager from scratch. Today's going to be a bit more of a conceptual day. Monday's going to be more of kind of an implementation thing. But most of what you're going to see on Monday is actually going to be stuff that you won't really need to know because we're going to give you packages that will do it for you. But it's still good to understand what's going on so you can help, or so you can better understand what's going on when you have to debug things. But so where we left off on Monday was we were passing this information from our app to a backend in JSON format. Right, so we have like fields, and then we have some values, and we want to. It's just a good way for us to kind of communicate between different things because we can have like this one central structure for our data. And so, as I said, we can kind of break it down into fields, values, and types. And hopefully, this is looking kind of like stuff you've seen in Swift, very much like structs or classes. And so that's where we're going to be kind of headed today. We're going to be creating objects which have names of fields that are corresponding to the names within the JSON. And then the types are also going to correspond as well. So here's kind of an example of how that might look. So right, we have name, and this is going to be a string, and it's mashed up. But you can imagine if you have a lot of these objects, it's going to be a lot of code to kind of saying, okay, get the value in the JSONs that's according to the name, and then set it there, and vice versa. And then if you have a lot of different types, you're going to have to be doing a lot of extra overhead. So that's a lot, and we're not going to handle that because we can just make our data structure conform to Codable, which is something that Swift has implemented for us, and it will kind of handle this going between of JSONs and objects for us. So on the left is an example of a codable object that we'd use. So it's a song. We're going to be building out a little app today that has just kind of like a very like Spotify Lite, like a very bad version of Spotify that can't play music. There's no photos or anything. But okay, so we have an ID, and that's just kind of something that pretty much all backends have, because you're going to be you can kind of think of a backend as having like a really big Excel sheet, and so each thing has an ID just so that they can tell each other apart. And then there's the actual information we want. So there's title for the song, there's an artist of the song, there's a length, which is stored in seconds, and then there's a timestamp, which is a date, which is another Swift type. And on the right is actually it's the implementation of the backend, which was done in Swift as well. Which you don't really need to understand what's going on here, but a brief overview is we have a bunch of routes, and they're going to be like the API, blah, 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 and then /songs. And then we have a few other routes, so we have get all songs, so you could just do songs /all. And then there's a few other variants here. So we have get a specific song, and it takes a song ID. This little notation with a colon beforehand means that it's a parameter that's going to be put into the URL, but this isn't a syntax you really need to understand. But again, as Justin said last time, we're going to be passing some information in the actual URL that we're going to be putting our get, post, delete, update requests. But there's a little bit more to that, and this is kind of where our song Codable will break down. Is if we look at what's going on in one of these routes. So this is the delete route. It has a song ID, so it takes the song ID as a parameter, but it also has a body, right? So when you're creating a JSON to pass the information, and from that, it's taking the artist, but it's only taking the artist, and then it will check if it's valid and delete it or whatever. But so it would be kind of annoying if we had to, create another struct that only had the artist field. Like, you can imagine if you were doing this for a bunch of routes, you would have, like, I don't know how many permutations. I'm not good at math. But, like, you can imagine you'd have to have one with ID and artist, or title and length. And there's so many different possibilities you could do. So, again, this is kind of a really another problematic area where you'd have a lot of code that's just kind of overhead. And so the fix to this is actually really easy. It's just to make all of the fields optionals. And so here's a little example of how the decoding will work. So converting from JSON into a codable object. And so we'll have, we have a length, which is getting put into length. We have title, which is getting put to title, artist into artist. But you'll notice we have two other things that are going on, which is we have a random field. So it's something that's not going to get used, and that will just get ignored by Codable. And then there's ID, which doesn't exist in the JSON. And so if it doesn't exist, because it's optional, it doesn't need to be set to anything, so it'll just be set to nil. Whereas if it were not optional and you passed in this data type or this JSON to get decoded, you'd get an error, which is not great. So most of actually we designed the homework so that your model is going to be optional fields. All of your fields are going to be optional, which just allows us, again, to kind of create any permutation of the fields that we want when we're passing information to the backend. Are there any questions about codables? Great. So now we have to deal with decoding information and encoding information. So decoding, we're taking a JSON, we're putting it into a model, which is pretty easy. We just use a JSON decoder, which is an object that's built for us. And then there's a function called decode, which takes a decodable protocol. So this is kind of like homework 1 when you have to pass in a type. So you do, if before when we were using that struct when I was showing like the course information, you do course.self. And then the data is where we're going to pass in our JSON, which we'll talk about next week. And then the opposite for encoding, the reason you need to pass this type when you're decoding it is because it needs to know which fields to look for. Whereas if you're encoding, it already has your object and it knows what fields are in there, so it'll just do it for you. Both of these functions don't actually take codable types. They take encodable and decodable. And that's because Codable is just kind of like just a tiny bit of a lie where it's not actually doing anything. It's literally just combining decodable and encodable. Oh, and when you conform your type to a Codable, you don't actually have to do anything. It'll handle it all for you. But yeah, so you'll pass in an object here, and for decoding, you'll pass in JSON data as well as a type. And decoding and encoding are slightly more complicated than what I showed on the last slide, because here's the function declaration. We actually have this throws parameter or tag on it, which means that there's errors that you'll have to handle. There's a potential that you won't actually get any information. It'll give you an error. So this is exactly like exception handling, error handling in Java or whatever language. And any function that throws an error, so if it raises an error, you have to mark it as throws. Otherwise, your code won't compile. So first we'll talk about raising errors so you can kind of understand how to use them. And then we'll talk about throwing. So raising is really easy. You just have to create any type you want and just conform it to error. There's nothing you have to do. And then when you want to say that, hey, there's an error here, you just throw it. And this notation is a little confusing. Abort is just a type that it conforms to error that takes in some enum. But for example, if we were to use request error, you just do throw request error dot not found or whatever. Just anything that conforms to error, you can throw it at any time. And that was pretty straightforward. But handling is a little bit less. We have 4 options on how to handle errors. We have try, and try. So try without any mark on it is basically just saying this line that I'm going to execute is potentially going to throw an error. And if it does, I'm not going to handle it. I'm just going to let whoever's calling this function handle it. Whereas try with a question mark is converting things to optional. So if there's an error, it will return nil. And if it's not, it will return whatever value was returned. And then just like optionals before, if you put an exclamation mark, you're saying, I guarantee this isn't going to give me an error. And if it does, you're free to crash. So the last thing the last way to handle it is with a do catch block. And catching is pretty advanced. There's a lot you can do with it, but you're not going to need anything beyond this. I would say catching is really helpful if you have some kind of behavior you want, if there's an error given, which you wouldn't really have beforehand with these. Because, for example, if you have try, you're giving it the behavior to someone else. If you have try with an optional, you actually don't get any like sight into the error or what's going on. It'll just run your code normally. And then obviously if you have try exclamation mark, you're just going to crash. And the reason why we're using errors when it comes to networking is because there's just so many things that can go wrong that if it just goes wrong and then crashes, like you're not going to get anything interesting. You're not going to know what's wrong. So that's why we're using these as errors here. But so for do catch block, we'll run our code until we find an error. And in that case, we will stop doing what's in the do block and we'll jump to the catch block. But if there's no error, we'll just finish everything that's in the do block and do nothing that's in the catch block. And you'll notice that try has to be done per function that throws an error. So that's kind of different than how you'd see it in Python. But the nice thing is you could put a bunch of tries in the same do block, so it's pretty similar. But so we're just going to run through this just so you guys, to make sure you understand what do catch is, because it's going to be really helpful next week when you're debugging your networking. So say that the decoding here actually succeeds. We're going to go to the decoder line, we're going to run, we're going to decode, and then we're going to store our data and decoded data. And then it's fine, and you'll just call the next function. Whereas if it fails, we'll do the same thing, we'll decode, we'll get an error, and then it will jump to catch block. You'll see that prints error. Error isn't defined anywhere, it's defined by your catch block. Just kind of, if you did sets for variable properties, it's like new value. And then it will call the completion handler and continue. So that's errors. We won't be touching errors today, but it is pretty important. So for your homework, the next 2 weeks we're going to be building out kind of a message board, somewhere you can post posts online with a title, a profile, and a body, and then you can like edit posts that exist, you can delete posts. But for this week, since we're not really covering how to do everything in networking, we're going to have you make a static app. So you're going to have information that's hard-coded, and then you're just going to manipulate it as if you were doing something online, but you're not actually. But what's really important is that you remember to show your changes that the network's having, because you have to make sure that you're synchronizing what the network has with what you're what you have storing locally. So review from last week, we have CRUD. So we have create. So for our posting app, we're going to be, whenever we post a new post, we're going to use post. Read, getting information. So for example, when you start your app up first, you're going to see a bunch of posts. If you make changes, you're going to need to reload it. Update, we didn't talk about that last time. Update or put, that's the actual name for it, is for changing pre-existing information. People get kind of lazy and will end up doing posts instead of updates or puts, which is fine. We're not going to be doing that. For this project, we are going to need you to do puts instead of posts, but it's a very minor change. And then deletes for deletes. But what's kind of important that you remember is that for create, update, and delete, that you need to show your changes in your local information. Because you could imagine you have some screen with delegation and you create a new thing and then you go back to the original list and then you don't update it. Or if you update a post, you go back and you don't update your list. So that's just something important to remember. And so for the rest of today, we are going to kind of forget about networking to some degree. And we're just going to model, if I were using a create, if I were using a read, how am I going to present it? And for the most part, you guys are more than qualified, to do all of this. Well, actually, you guys completely are. But what we're going to be doing today is there's a few extra functionalities of table views that are going to make this kind of easy. So for creating, it's nothing new. It's just delegation, so we're not going to go much into that. But for reading, so if you already have your information and you want to reload it, we have a nice drag down reloading thing, which is really easy to do, so we'll do that. Update is also back delegation, not very hard, or nothing new. And then deleting, we have to implement this draggable function. So that's what we're going to be doing today, is the read and delete. But there's one topic we haven't talked about. This is an extra credit topic for your homework, so if you're not interested, you can totally tune out until the demo. But so far, we have only talked about information that you're getting from the network. You're showing it, you're changing the network information every time. But every time you close your app, you kind of lose everything, unless it's stored on the network, of course. But there's certain things that you might want to remember, like you want to remember your login and password so that you don't have to ask the user for it every time, or you might want to cache some information so that it's faster load speed, or maybe you want to download some songs so that a user can play it when they're not connected to the internet. So that's kind of a problem with what we've had so far, is everything relies on the internet. And the solution to this is something called UserDefaults, which is a package. I don't really know the official name for it, but something that you can use to save and load information on your device. So what you should be looking at right now is these two functions at the top. So we have set, which takes in a value, any type of value, can be optional too, and just sets it for a name. So we can just kind of think of UserDefaults as a dictionary with string keys. And then value, this is the same idea. So if it's a dictionary with string keys, we just put in a string and then we'll get the value out again. And I will say there's a lot of ways you can do this, and there's a lot of ways you can make your life easier. So here is my implementation of a login page for Spotify. And so we only have two things we need to store. We need a username and a password. And then, so like if I'm just using username and password a lot, I kind of want to reuse constants, because I don't want to type it out every time and potentially misspell things. So what I did is I just created an enum, so username and password, so it's every time I get it, 100%. UserDefaults.standard, this is actually where we're going to get, this is our dictionary, basically. This is what we can call set and value from. And then I made just a few nice little additions. This is completely unnecessary, where I just made a variable which is gettable and settable, which will call set or get value for us, and then just a combination of the two, saying if I don't have a password or username, make them log in again. All right, so now we're on to the demo. I'll show you what we have so far. So if we load it up, it's kind of Spotify. We have a table view, we have a navigation header, and then if I click on the cells, I can kind of play around with them, but I think actually updating is set already. That's not something we're touching today. But we have no way to add songs. We have no way to delete songs. If you click on it, it'll just put this update screen. And we have no way to refresh. So those are the three things we're about to do. So first things first, we're just going to add a refresh. So how do we add a refresh? It's something called refresh control. Is the font big enough for you guys in the back? Yeah, great. So to create something for refreshing, we just create a UI refresh control. And then because I'm putting on a dark background, I need to tint it to be light, because otherwise it's dark and it's hard to see. So this is just as you would for buttons or for images. You just set the tint color. And I created a theme, so I'm just going to call it, set it to be the text color. And the only thing we have to do to set it is just get the table view. So in this case, I called it songs view, and just set the refresh control to be refresh control, or to refresh. And now if I load it, I can drag this down, and it should reload. Oh, there's one thing I missed, and that's to set a target, because this will function similarly to like a button. So I just need to do refresh.add target, and so I'm just going to add self. It's a selector, so I already have a function for this. It's called populate songs. And then I'm going to have this trigger whenever the values change. So we can think of this as like the height, whenever it's changed. So now if I reload this, hopefully we'll actually have a reloading thing. Great. It's fighting me a little bit because it's a simulator, but it is there. And then I can prove to you that it's actually doing something by adding more songs to the database. So I just added more songs. And then if I reload, there's more songs. So next thing on the to-do list is to add something for creating new songs. I want to add a little plus button. I want it to be very minimally intrusive. So I'm just going to put it in the navigation header. So one way I can do this is, well, I've already created a button. It's called add song button. It's defined up here, nothing too special. And to do this, I can just say, so navigation item, so the item at the top of the screen. I want to set its right bar button item. So I'm literally just saying I want to put a button on the right side of the screen. And then I'm just going to set it to be the add song button. And then if you do this, it'll be default colors. It'll be like blue. So I'm just going to give it a tint to keep it like with the theme of everything. So I'm just going to say add song button dot tint. And if you're not sure how to get like a nice little plus sign, obviously you can do it with text, but you can also define it with this UI bar button item with an add. And actually, yeah, sorry, I said this was a button, but it's not a button. It's almost a button. It's a UI bar button. But so now if I press plus, it brings up this new screen. It calls the function I wanted. And then to prove to you that it's updating, I'll say new song by Noah, and it's not very long. And then if I add it, update it, and it said new song. So that's great. And then if I reload, just to promise you that it is actually in the database, it says new songs at the top. That's great. So last thing we have to do is this deletion with the table view, which is probably the hardest part, but it's not too much. So first things first, we have to create an action that will be executed when we swipe our cell to the left. So I'm going to create a action, or sorry, delete action is a UI contextual action. And I'm just going to initialize it with style, title, and handler. And style, I'm just going to set to be destructive because I'm going to destroy the cell afterwards. Title, I'm just going to say delete. This is what's the text that's going to be showing up on it. And then handler, this is going to be a function which is run, once it's selected, once it's activated. So if I press enter to initialize this, you get this more scary thing. But this is just a closure. It's an anonymous function that'll be run. So we'll see that it has three fields, three arguments, which is the action itself, which I don't care about, so I'm just going to put an underscore. The view that's related to, which I also don't care about because I really just want to change my data and then reload things. And then a handler. So this is if you were to say that, I don't actually, the user thinks that they want to do this, but given some criteria or whatever, I'm not going to let it happen. So in that case, you would say, this is a function that takes in a bool, and if you put true, it's like, okay, delete. And if it's false, don't delete it. So I'm just going to name this handler because we do actually have to deal with this. And this is the handler I have built out. It uses networking, so you don't need to understand that part. But the idea here is we're going to take our song, and assuming that it's a valid song, so it has an ID and an artist that exists, then I'm going to push it off to the back end to delete it. Because I don't want to push off an invalid song to the back end, because that would be kind of scary. So, and then if this is successful, it will return true. And if it's not successful, it will return false. So I'll just say, I can call handler, so it takes true or false, of delete song. And then the song is just my song's index path item. And this is nothing new. But it does require self. And this is slightly more problematic than normal because this can potentially create cycles. You guys aren't going to be liable for this kind of cycle. It's hard to deal with. But for those of you who are curious, what we can do is the problem is that we're going to be taking this contextual handler or action, and we're going to be giving it a pointer to self. And self also has a pointer to this, so that's why we have a cycle. So the way to fix this is we'd normally make some weak protocol and then assign it. But that's, like, you could do that. It would kind of suck. I don't love protocols in this thing. I feel like protocols are kind of scary. So what we can do is we can just declare self to be a weak variable. And the way that we do this is just by saying weak self. But the problem with weak self is if something is weak, it has to be optional. So then we have to make these optional when we call it here. And then that kind of cascades and it gets harder. So I'm just going to say if let self equals self. If it exists, then I'm going to just call handler on self.deleteSong from self.songs next path.item. And then otherwise, if that doesn't exist, I'm going to just say, I don't know what to do if self doesn't exist. That seems like a very nonsensical thing. So I'm just gonna abort because I'm scared. And then, okay, so now that we have our action set up, we actually need to make it into a view. And then the way that we do that, well, it is kind of already a view, but it's not something that can be added into a table view. So we can actually set the background color. And I'm just going to set this to be red, which is my destroy color. And the way that we can actually implement this, because the table view is asking for a UI swipe action configuration, we just return a UI swipe action configuration, and it's going to take a list of these. If you remember, if you've ever used the Mail app on your phone, you'll see if you swipe over, you'll see a bunch of options like archive, flag, blah, blah, blah. So you could put in a bunch of these if you wanted to, but I just want delete. So I'm just going to put a list with this delete action. And then if I run that, I think that should work, hopefully. And so great, it's gone. And then if I reload that, and it's still gone. So those are the 3 tools that we're going to give you to help you with your homework this week. Of course, you don't have to use it if you don't want. You can use things you find on the internet as well. This homework is very much you can design it however you want. As long as it has the functionality, it's good. So, yeah.
Yeah, so 2 things. So I've already finished making the mentorship pairing groups. I was going to announce it at the beginning, but I forgot. That's my bad. But I'll announce it now. Your mentors should have already reached out to you. If they haven't, they should. But I guess I can just show the pairings right now, actually.
I will say all of this demo code is uploaded. I mean, not the stuff that I just did. And it's pretty much a lot of what you need for your homework. I will say for things like Default Manager, if you want to understand it, the more you do by yourself is good. But, if you like the code, you can use it. So, yeah. Do you think you put it on? Could you send it to me? Okay. And what is...
Oh, I'll just airdrop it to
you. Yeah.
I have 2%.
Oh, okay.
Where is this demo uploaded?
It should be uploaded in the second part of networking 1. It should be demo 2. If it's not there, I will upload it immediately after lecture.
Oh, cool.
And then just open it.
So here are the pairings.
Yep. So these are the pairings. Some of the groups are like in two because they requested, but they will be reaching out to you. They should already have. If they haven't, they will definitely reach out by the end of today. I'll remind them multiple times. So yeah. If you guys have any questions about like anything, you can reach out to them. They're all very nice people. They don't bite. Yeah, I don't have very much to say about this, but I hope like the whole point of this is just for you guys to have like more of a sense of community when taking this course. So I know that sometimes like this being a very late class, not a lot of people show up because they're either tired or the other classes in conflict. They take it asynchronously, so they feel like they only know people in the class. So I feel like this is a way for you to get to know each other, and hopefully you guys have fun. Yeah, another thing, so this is the second lecture of this week, so that's the end of the lectures for this week. You should already have everything you need to tackle the project for this week, which is P5. So, it's always good to get an early start, and as always, if you have any questions, you can post on Ed or reach out to us. Okay, cool, that's the end of lecture. Yeah, do you want to...